Welcome back, Mac Marbles. This is lesson 76, finding the area of the shaded part of the figure. So while I'm modeling, I want you to look out for these 3 things so that you can practice them as well and show mastery. 1, watch how we decompose the polygon into really familiar shapes, triangles, and quadrilaterals. Then in part 2, calculate the area of both triangles and quadrilaterals. And then finally find the total area by adding up all those little triangles and quadrilaterals. And that is how we find the area of an irregular polygon using a sound strategy.
Here's our first problem for today. Here is a design for a stained glass window. What is the area of the purple part of the design? So to find just the area for the purple part, what we're going to do is we're going to find the total area and we're going to subtract the green diamond, or the area of the green diamond. So that's our overall plan. So let's start by writing out our actual formulas. First thing, before I can do that, I'm going to decompose this figure. Let's break it up into some easy to see and easy to calculate figures. So just by making those 2 cuts, I have 2 triangles on the end that are the exact same size. And I have a rectangle. So the first part of my formula is going to be, I'm going to do the 2 triangles first. So 2 times 1/2 times base height. And I'm going to add that with the area for our rectangle, just the length and the width. For the part I want to take away, I'm going to give myself some space. I'm going to subtract. For my big piece over there, I'm going to split it into 2 triangles. So it's going to be 2 times, again, 1/2 base height. That's going to be the green part I'm taking away. All right, let's do some substitutions. So 2 times 1/2. Here's the base of the triangle I'm going to use. I'm going to use this as the height. So base and height. And our base is 1, 2, 3, 4, 5, 6. And our height is 1, 2, 3, 4, 5. And for our big part over here, from here to here, well, I know this is 6. I can see that part. And it tells me over here, from here to here, is 24. So 6 times 24. Awesome. That's going to tell us the area of the whole big part. And we're going to subtract 2 times 1/2. Let's do the base of the triangles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the height would be 1, 2, 3. Awesome. Perfect. Hit pause so you can jot this part down into your notes. Great. I brought out our calculator for the next section so we can multiply a little bit more quickly. For this first part, triangles, we have 2 times 1/2 times 30, or 2 times 15, which gives us 30, plus 6 times 24, which gives us 144. So we have our total part for the area, and we're going to subtract from that last little triangle part. So 2 times 1/2 times 30, which is also 2 times 15, half of 30 is 15, or 30. So here's our final part to find the area of just the purple part. We have 30 plus 144 minus 30. I see a 0 pair there. So 30 minus 30 is going to be 0, so that's left with 144. The area of the purple section is 144 centimeters squared. Let's box our final answer and hit pause and jot this down into your notes. Summer needs to paint around the door. Which expression could not be used to find the area of the wall? So we're going to look for one of these cannot be used. Which one is it? So for this one, I'm going to use my highlighter just so you can see each section. We're going to try each one at a time and see what it represents in the drawing. So for this first one, the first part is 20 times 25 minus 5 times 12. So where are they getting 20 by 25? So it sounds like they're doing this whole thing, so this total area, minus 5 times 12. So would this be a valid way for finding the area? Let's take a look. So it would be for finding the area of this entire rectangle, that's yellow, but then we're going to subtract this part over here because that part would be 5 times 12. That would be a valid way to find the area. So we can eliminate this choice. All right, let's clear this up again. I love a visual. Here I have 10 times 12, 10 times 12, and 8 times 25. First, let's try and find the 10 times 12. And that would be, here's 10, here's 12. So that would give us, this would be the area of that section. 10 times 12. And then the next part is plus 10 times 12. So that would mean another 10 times 12. So this section. And the last part, 8 times 25. I see a 25. Where do you think they're getting the 8 from? The 8 would be this section right here, from here to here. Because I know this part over here is 12, this second part over here has to be 8 because the total area of this side is 20. So this is 25 times 8. So you can see this is another way of showing decomposition. This one's also valid. So we're gonna cross that one out. That one can be used. All right, let's do another one. We have a few expressions here. We have 10 times 20, 10 times 20, and 5 times 8. And those three products are going to be added. So we already know where the 10 times 20 is coming from. Here's 10, here's 20. So that's this part over here. And then another 10 times 20, that's this section. And here's 5, and we already know from here to here is 8. So that would give us the area as well. So we're going to cross this one out. And let's confirm where the last one might be. Just by process of elimination, we're pretty sure this one cannot be used to find area. But let's go through it either way and see what the parts are. So the first one is 20 by 15. 20 by 15. Where can we possibly get 20 by 15? Okay, so I see a 20. Here's 20. And here's 10. And if we added 5 more, this would be 15. So that definitely covers the door. And then we're adding 20 times 10. So here's 20 and here's 10. So why doesn't this work? Take a moment to really think about it. Why does this method not work for finding the area around the door? Well, because unlike the others, they included the space for the door. So this one cannot be used. And I'm going to put it in for reasoning. Incorrect. This expression includes the area of the door. And jot this one down into your notes. Math Marbles, the biggest takeaway for today is we can take real visuals, and by decomposing our figures, we can find the area of these complex polygons. And it is sometimes really helpful if you have different highlighters to actually color and help you see a little bit more easily how you can decompose the shapes and how you can express those in an expression. Just have each area as a product in your expression. That's it for today, Math Marvels. Take your time and get feedback from others, and I will see you in the next lesson. Be well.